We copy you down, Eagle.
Right now we're here at the VR lab, virtual reality lab, and it's a graphical rendering program that models everything on the space station from decals to fluid lines, electrical lines, anything that the crew might see outside on the space station. We model in here so that when they go outside, they feel like they've already been there because they've been here in their virtual world. So when we put the crew members in the helmets, they get this 3D virtual world of this space station. And we can put them anywhere on the space station, in the Russian segment or the US segment, the Japanese or European segments. And what they'll do is find out whether the work site works for them, the way the suit works, and whether they're in the right place to be able to handle the tools, be able to take the unit out and be able to replace the unit if they need to. Up on top is the tracking system, and that allows us to track the motion of the head and where he's pointed so that we can change the scene inside that he's looking at. Same thing with the hands. We also have force sensors inside the palms so that we know when he grabs his hands, and we can model that in the simulator. It is something that was actually built by the engineers here. He built the entire helmet in his garage. So, okay, what we have here is our Charlotte robot, and what these strings provide is the capability of a crew member. When they're standing, you can see that they have we have a handrail on it, and we can change out these handrails to make them look like any kind of different type of what we call an orbital replacement unit. In other words, a spare part that might be on board the station that we may be either putting on to a platform or taking it off a platform, putting it into its original slot or taking it out of its original slot. And so what this gives you the capability of simulating is anything from like 200 pounds to 1,000 pounds on the Earth, but really doesn't have any weight in space, but it still has a mass, and it still has moments of inertia, and it still has a center of mass. So if like this handrail, I was trying to work and try to get a piece of equipment into a certain slot, and I'd be able to grab this handrail, and in my vision, I would see the real ORU in front of me, not this robot. But I'd see this handrail, and I'd be grabbing the handrail, so I'd be looking at the ORU moving, and this robot would move instead. But this is what they call the SAFER unit. It stands for Simplified Aid for EVA Rescue. And it goes on the back of the Portable Life Support System, also known as a PLIS of the EVA crew member. So on the back of their suits, they put this unit on. And what it allows them to do is if they ever become ungripped and they start floating away, then this unit will provide the capability of having them have a safe return back to the station. What they'll do is deploy a hand controller that's over here, start the system up, and then stop their rotation, find the station, and then fly back to it. It works on nitrogen, pressurized nitrogen gas. There's nozzles, top, sides, back, bottom, so that they can control their rotations, their spin rates, and their translation rates. When the EVA crew member's in the helmet, they will be somewhere on the space station, and what we'll do is we'll kind of just throw them off the space station in the virtual world. It'll take about 30 seconds for them to get the hand controller system out, power up the system, get it checked out and ready to go, and then they'll stop their rotation. They'll need to find station, and once they found station, then translate back to it.